Okay, another way to use matrices on an application of matrices are to use matrices and determinants to find the area of a triangle, given the 3 points on a triangle. So let's say we have these 3 coordinates, and those are vertices of a triangle. Alright, so it looks something like this. Alright, one way you could find the area is to apply this formula here. So it's 1/2 times the determinant of the 3 coordinates as the first 2 columns, and each point goes together in the same row, and the last column is just all ones, and you multiply it by 1/2. This is like the base times height. That's the 1/2 times base times height, and the plus or minus means that the determinant could be positive or negative depending whether, even though the area is always positive. So if you get an answer that's negative, you just apply this negative here, and you take the area that's positive. So no matter what, an area is going to be positive, even if this number gives you a negative. So we're going to do 0.5 times det, the determinant of a 3 by 3. And I'm going to type in my first point here, -4, 1, and then a 1 there. And then the next point is -1, comma, -4, and then a 1 there. And then the last point is -1, 3, and then a 1 there. Hit enter, and our area is 10.5. Whether that was positive or negative, if it came out to be negative 10.5, the area would still be 10.5. And if we look at this here, we see, well, it has a base of 1, 2, 3, 4, 5, 6, 7, and a height of 3. So 3 times 7 is 21. Divide that by 2, and you get 10.5. Now, you can also use this to find the area of a parallelogram. Now, imagine I had another point here, or let's say, so a parallelogram has opposite sides that are parallel. So let's say I constructed a line parallel to this line through this point, and a line parallel to this line through this point. Now, this is not the only parallelogram you can make with A, B, and C as vertices, but it's another one. But notice how the area just doubles. So if I was trying to find the area of this parallelogram, A, B, C, D, with these vertices, the 3 from the original problem, and then the third with this new point, 2, -2, then you would do the same process, just use 3 of the points, but don't multiply it by 1/2, because the area of the parallelogram is just base times height. So the area of this parallelogram here is going to come out to be 21. And if you don't believe me, you can use the area tool here, click on that, and you get 21. Alright, so any parallelogram that has A, B, and C as vertices will also have an area of 21. Alright, let's say I did it another way. Let's say I made one like this, where, okay, let's make this a diagonal. So I'll make this side parallel to that side, and this side parallel to that side. This whole parallelogram is still double the area of that triangle, which had an area of 10.5. So this parallelogram would have an area of 21. So again, if I said find the area of a parallelogram with points -4, 1, -1, 3, -1, -4, and -4, -6, you could use the same process on the calculator. Just pick 3 of the vertices. So we'll use the same 3 from the triangle, and then don't multiply it by 1/2, and you get the area of the parallelogram. So that's a third application of matrices.